Good morning. In this video, we are going to solve a problem in product moment of inertia. In my last video, we discussed about product moment of inertia in detail. I have given the link of that video in the description. Those who have not seen that video, kindly go through that. In that video, we summarized three important things regarding product moment of inertia. The first thing is that if the moment of inertia is with respect to x-axis, then y variable play an important role. If the moment of inertia is based on y-axis, then the variable x will play an important role. But in the case of product moment of inertia, both x and y variable play an important role. This is the first discussion. Second discussion was like the product moment of inertia can be positive or negative or even zero also, but the moment of inertia will always be positive. Then that discussion is for an axis symmetrical sections, the product moment of inertia is zero. So these were the discussions in the last video. Now let us go to the problem. Find the product moment of inertia of the following inverted T section with respect to x and y axis passing through centroid and the base axis. Now this is the given inverted T section. The first step is I have to divide this composite object into a small sections, irregular shape. So here is the first section and here is the second section. And if you look at the dimension at all, the first section has 10 meter width and this height is equal to again 2 meter. For the second section, the height is equal to 8 minus 2, so 6, and width is equal to 2 meter. So this is what here also I have done. Here the first rectangle, here is the second rectangle, and when you add this one, you will get the final rectangle. This is the first step. Now in the second step, we have to take the first object, the first rectangle, and draw a separate diagram, and then we have to find the values for these variables. Okay, when you draw this diagram, make sure that these axes are correctly positioned, okay, with respect to the given composite section. Now let us go to the first variable. First variable is x1, which is nothing but the position of this g1 with respect to y axis. So here is the x1, which is nothing but half of this distance, so 10 by 2, 5 meter. Then the next one is y1, which is again the distance between g1 and y axis, which is also half of this height, which is 2 by 2, 1 meter. Then that one is this area. I will come to this next. Area is nothing but multiplication of these two, 10 into 2, which is equal to 20 meter. Now let us go to the fourth variable. Okay, the important variable or the new variable has been introduced in this problem, which is nothing but I x1 y1. Okay, I x1 y1, it is nothing but product moment of inertia with respect to the axis passing through g1. So this is y axis and this is x axis. Now the product moment of inertia with respect to this axis, okay, for this rectangular. But you see here, it is a axis symmetrical one with respect to y axis. Okay, it cuts the object. If you look at both the sides, they are similar in size and shape, so it is axis symmetrical one. Similarly, with respect to x axis also, it is an axis symmetrical. So as we see, as we saw in the last video, for the axis symmetrical section, the product moment of inertia is 0. So this is what here it is put as 0. Here it is written. It's very important one. Now for the second rectangle, again we are going for the all four variables x2. Here the second rectangle is located from y axis by 4 meter. So this is 4 meter. So we have to add this 4 plus 2 by 2. Again this width is 2, so 2 by 2, which is equal to 5 meter. Then y2 is again the distance between g2 and this x axis. Here this distance is 2. Okay, so we have to add these two. So 2 by 6 by 2, which is equal to 5 meter. Then area multiplication of 2 meter into 6 meter, so 12 meter square. Again the fourth variable, very important variable, I x2 y2. It is nothing but the product moment of inertia with respect to this axis. This is x axis and this is y axis. So the product moment of inertia with respect to these two axes. Obviously here also it is axis symmetrical. Okay, axis symmetrical. So when it is axis symmetrical, the product moment of inertia is 0. Similarly, with respect to x axis also it is axis symmetrical. So the product moment of inertia is, here it is 0. That's very important thing to note. Now the third step is finding the centroid. It is needed to find the moment of inertia with respect to centroidal axis. So this step is very important. Now by using the common formula, x bar equal to x1 y a1 plus x2 a2 divided by a1 plus a2, substitute the values, you get the answer as 5 meter. Similarly for y bar also use this formula and substitute all the values, y1 a1. We have found all these values in the previous step, second step, and finally we get the answer as 2.5 meter. So x bar equal to 5 meter and y bar equal to 2.5 meter. Now that step is, we have to find the product moment of inertia with respect to centroidal x axis and centroidal y axis. So here is the centroid and this is centroidal axis x dash, and here is the centroidal y axis which is nothing but y dash. Now the moment of inertia with respect to centroidal x axis and y axis, which is nothing but I x dash y dash equal to moment of inertia with respect to the first rectangle, then moment of inertia with respect to the second rectangle. Now you see here, I know the moment of inertia with respect to this g1. Okay, we already found in the second step. Now we have to find the moment of inertia about this capital G. Now you see here, these two are parallel to each other. Okay, if we take this axis, x axis, now x dash as well as this x, both are parallel to each other. Similarly y axis, this is y and here is also y. These two are parallel to each other, so I am going to use parallel axis theorem. Okay, so here I am going to use the parallel axis theorem. So I x1 y1, which is nothing but the product moment of inertia for the first rectangle, plus in this place it is the distance between G and G1 and capital G. Okay, so with respect to y axis, so this is the distance x bar minus x1, and here also the same thing, the distance between G1 and G, but with respect to x axis. Okay, so here you see here, this is y1 and this is y bar here. Now I want to know this distance, so which is nothing but y bar minus y1. So here it is written y bar minus y1. Okay, with respect to x axis, it is with respect to y axis. Now again area a1. Okay, so this is what the parallel axis theorem in product moment of inertia. Okay, for the first rectangle. Similarly for the second rectangle, the same formula, but the notation is changed, x2 y2, here also x2 y2 and here a2. Now substitute all the values, but you see here both x bar and x1 are same, so multiplication of this is 0. Similarly this value is also 0, already we found in the second step. Similarly here also you see here this value is 0 in the second step, already we found. Moreover x bar is 5, x2 is also 5, so this will also be a 0. So ultimately you see here I x dash y dash is 0, because you see here this is the composite section, inverted T section. Now this is the centroidal y axis, so this is centroidal y axis. Now with respect to this axis, you see here, with respect to this axis, the both sides are similar, so it is axis symmetrical one with respect to the centroidal y axis. Okay, if it is axis symmetrical with respect to any one of these axes, then the product moment of inertia will be 0. So this is what we discussed in the last video also. Now it is proved. Now the fifth one is product moment of inertia with respect to base axis. Base axis is nothing but the moment of inertia with respect to this axis as well as this axis, OY and OX. Now here is the formula, IXY equal to moment of inertia with respect to the first rectangle, then moment of inertia with respect to the second rectangle. And again I am going to use the parallel axis theorem, but here in the place of x bar minus x1 I am going to use directly the x1 and y1. Okay, now with respect to x axis, okay, so this is the x axis and this is the axis passing through this g1. Now the distance between these two is y1 only. Similarly, this is y axis and this is the axis passing through this g1. Now the distance between these two is x1 only. So the formula, the parallel axis theorem is modified as I x1 y1, which is the product moment of inertia for the rectangle, then x1 and y1, okay, x1 and y1, then a1, okay. So this is a very important thing, okay, but here I have used x bar minus x1 because it is moment of inertia with respect to centroidal axis. Here it is base axis. Similarly, for the second rectangle, in the place of 1 you just substitute 2. So this is the moment of inertia for the second rectangle. Substitute the values, finally you will get the answer as 550 meter to the power 4. So the conclusion is the product moment of inertia with respect to centroidal axis is 0 since the centroidal y axis cuts the object into two shape, which is nothing but is axis symmetrical one. So it is now 0. For the second case, the moment of inertia with respect to base axis, which is having a positive number, say 550 meter to the power 4, because most of the materials are in the first quadrant, so that the answer is positive. So that's all about this problem. In the next problem we will see the principal moment of inertia. Thank you.